Hello students, now class 11th I am taking the chapter 3 that is the motion in a straight line. When we talk about the straight line, it means that the length of the line is very large and its thickness is very small. So the motion of the body when it is moving at a path whose length is very high and width is very small, then this is taken to be straight line. Actually, that you have also studied about the coordinate system. That is the x, y, z having the dimensions. So this either the body moves along x-axis or moving along y-axis or moving along z-axis. Then this is the motion in one dimension. That we give the name straight line motion. If the body moves in a plane like this xy plane, yz plane, zx plane, then this is called the two-dimensional motion of the body. When the body moves in the space, all the three dimensions are there, then we call this now three-dimensional motion of the body. So, we have to study here the motion in a straight line. When a body moves along a straight line, it is called straight line motion. Suppose we are having the three axes, this is now 0, x, y and z. Then body moving, motion along x-axis or y-axis or z-axis. Then this is called the straight line motion. This is the straight line motion. Straight line motion. Suppose a vehicle is moving on the road, then this is also a straight line motion, because the width of the road is very small in comparison to the length of the road, and that we name that the body is moving along a straight line. So all the motion that we are considering here, which are in a straight part, then this is called the straight line motion. Now when we talk about this motion, then there are certain physical quantities which are very important to understand, because they are related to your class 11th and also to your exams which are like the NEET exam, etc. So like the distance, displacement, and that the speed, velocity, and then acceleration. So I will take one of them one by one. So first I am taking the distance and displacement. distance and displacement. So here in this topic today I will take only so much. Topic is distance and displacement. Distance is what? The length of path followed by moving body. Is called distance. तो लेंथ ऑफ द पाथ कितना भी लंबा हो उसकी जो भी आप लेंथ निकाल लेंगे वो डिस्टेंस कहलाएगी। आप एक पॉइंट से दूसरे पॉइंट तक जाते हैं तो कितने भी आप पाथ फॉलो करो उन पाथ की जो भी लेंथ होगी वो उनकी डिस्टेंस कहलाएगी। यूनिट मीटर होती है इसकी ऐसा यूनिट ऐसा यूनिट। The small distances are measured in meters, centimeter, inch, foot, and large distances are measured in kilometers, hectometers, decameters, and also we have the large distances like the astronomical distance, the light year, and then the parsec, etc. They are very large distances. So this is measured in the meters. So SI unit of this is equal to so much, and this distance is a scalar quantity. It has no meaning that from where you have to measure the length of the path. Either you measure it from the initial point to the final point, or the final point to the initial point. Then whatever length you are getting, that is the distance. Distance is scalar quantity. So it has no direction at all. Suppose you are moving through different paths between the initial and the final points. So whatever the path is followed, that is the distance. It is the maximum length of path. Now the displacement. Displacement the distance move in certain direction is called displacement. or the minimum distance between initial and final points of the path is called displacement. The distance moved in a certain direction. Here we are concerned with the direction. Is called the displacement, or the minimum distance between the initial and final points of the path is called the displacement. So this is the minimum distance. Then you can have that. This is also the distance. This is also measured in meter. The unit is meter. Meter. And now we can have its dimensional formula here. Dimensional formula. This is your N0, L1, T0. Similarly here, dimensional formula N0, L1, T0. And you can have that, so this is a vector quantity. Displacement is a vector quantity. So now I will give you some example of this distance and the displacement. Example. This is a path. This is now, you suppose this is now 0, this is 1, this is now 2, this is now 3, this is now 4, this is now your 5. This is now 5. So much. An object moves from here. This is now object moving from here. And then it goes up to this point. This is now O, and this point is, final point is the P. Now when the body is moving in the same direction, then the distance and displacement are the same. The distance OP is equal to, suppose 5, you take in meters. Meter. OP is equal to 5. Displacement this is also equal to 5 meters. So the body, when this is moving in the same direction, the distance and displacement will be equal. Hence, for a body moving in one direction, the distance and displacement. Are equal. So what we say that distance equal to displacement. So we have the relation that this or distance upon displacement upon distance. This is equal to 1. But this is when the body is moving in one direction. This we take now example 1. And now suppose this body moves. Now the second case I take here, that this is suppose 0, this is 1, this is now 2, this is 3, this is 4, this is your 5. This is now point P. Now the body moves from here. And this body then goes up to this distance. Up to this mark 3. Up to this one. This is like this and then 2. This is suppose the point Q. This is now Q. So what was the distance traveled by this body? Distance is equal to, this is now your 5, then 1 meter and this is now 2 meter. So now 5 plus 2, this so much. This so much is the 1 meter, this so much is the 1 meter. So 1 and 1, 2. This is now 1 meter. So that to so here is body goes and then it comes back. This is now your point Q. This is now your P. Here the point P. And this distance, this is also 1 meter. This is also 1 meter. Then what we have? That's 5. 1 meter plus 1 meter is 2 meter. So this is 5 plus 2. This is now your 7 meter. 7 meter. Now then what about the displacement? Displacement. Displacement. This is equal to 5 meters so much and 2 meters in the back direction. So this is now your 5 minus 2. So this is equal to 3 meter. 1 meter and 1 meter. This will be less because now the body is moving in the opposite direction. So here the displacement will be equal to 3. Moreover, you can see this is the initial point, this is the final point, and then this distance is 3 meter. This so much equal to 3 meter. So minimum distance between the initial and final point. So this is the minimum distance, that is now 3 meter. This is now displacement. So here, when the body moves in the opposite direction, then the displacement is always less than the distance. Now I take this another example. Suppose this you are given a circular path. This is now center. The radius of this one is so much. The object starts from this one. This is now initial point. Initial point. and then it moves from here to this, and then to this, and then this. I take the different points. Suppose you are given this is now this is now your P. This is now suppose point A. Here the point B. Here the point C. Here the point D. I am taking different situations, but they are standard one. Moving from A to B. What will happen here? The distance in this path, this is the 1/4 of this circumference. So this is now 2 pi r upon 4. So this is now your pi r upon 2. Now then, what is the displacement? Displacement. What we have? This is now your this is now your O, this is now A, this is now your B, this is now R, this is now your R, then this is now right angle triangle. So R root 2, and you can see that this displacement is less than this one. This is now your 3/2, 3.14 upon 2. So this if you divide R root 2, right. And now moving from A to C like this. Moving from A to C. A to C. Now then distance is equal to 2 pi r upon 2. This is now half of this circumference. So this is equal to pi r. And now displacement will be how much? Displacement. This is equal to AC. This is equal to now 2r. This is the minimum distance AC. This is the diameter of this circle. So here the displacement is 2r and distance is how much? Pi r. And while going from moving from A to B and then to C. A to B, this is now your C, and C to D. So the point is here at this one. A say B, B say C, C say D. So this is now 3/4 of the circumference. So distance is how much? Distance is equal to 3/4 into 2 pi r. This will cancel by 2. So this is equal to 3 pi r to 2. And now displacement is how much? displacement. This is equal to r over 2. Again, like this one. This is now between these 2 points A and B. So now displacement is r over 2. So now in one complete rotation, moving from A to B to C to D and then to A means closed path. It is closed path. Closed path. Then distance is how much? This is now your 2 pi r. The circumference of this circle. And now displacement, this is not 0 because यहाँ से इसी पॉइंट पर चल करके और इसी में वापस आ जाती है तो इसका डिस्प्लेसमेंट 0 के बराबर होगा। इसमें कोई इसका डिस्प्लेसमेंट नहीं होगा। तो आप क्या देख रहे हैं? इससे आप क्या देख रहे हैं? नाउ दैट डिस्प्लेसमेंट मे बी 0 बट द डिस्टेंस इज नेवर 0. Hence, the distance is never 0. Displacement may be 0. जैसे हमने यहाँ दिखा रहे हैं डिस्प्लेसमेंट इसका 0 के बराबर. तो अगर कोई बॉडी एक रिवॉल्यूशन लेती है, एक कंप्लीट साइकिल घूमती है, तो उसका डिस्प्लेसमेंट 0 के बराबर होता है. तो यहाँ से आप क्या कह सकते हैं? भाई यहाँ इसमें डिस्टेंस और डिस्प्लेसमेंट का जो मान होता है वो अलग अलग होता है. Now we can have the difference between distance and displacement. Now if we have this, now suppose your distance and this is now suppose your displacement, then what is the difference? That this is the scalar quantity and this is now vector quantity. Vector quantity. And second is distance is never 0 for moving object. And here the displacement may be 0 for moving object. And second is that when the body is at rest, then displacement and distance both are 0. For a body at rest, the distance and is not there. The distance and displacement both are 0. Both are 0. And one thing, the relation between the, I have told you that with the help of these examples, that when the body have the distance and displacement, then displacement is always less than the distance. The displacement is always now we have a relation that displacement is less than equal to distance. This is a very important relation. And we can have a relation that one more from here. The displacement upon distance is less than equal to 1. इसमें क्या है, डिस्प्लेसमेंट डिस्टेंस के इक्वल तो हो सकता है लेकिन उससे ज़्यादा नहीं हो सकता है. So displacement is always less than the distance, but it may be equal also when the body are moving in the same direction, and or if the body is at rest, then distance and displacement are the same. So this is what the about distance and the displacement. I think that this must be very clear to you when I have told you with the help of these examples. Also remember that suppose we take one more example, that the body moves from A to B. Suppose this is now point A, this is now point B. Then this is now shorter distance, and it moves like this, and then it moves like this. There are 3 paths. This is suppose your first, this is now your second, this is now your third. The body moves from A to B along the 3 paths. Body moving from A to B through paths first, second and third. Then you will see that displacement is how much? Displacement in first path equal to AB. That this is now we are giving the point P, this is now you are giving the point Q. And that distance will be how much? इसको ये फर्स्ट टर्म और ये इसको सेकंड और इसको बाद में लिखेंगे. First and second. So the distance, this is equal to in path first equal to A, P, B. This is not so much. And distance in path second, this is equal to A, Q, B. So displacement is so much. This is not displacement. This is not displacement. So what we see that this displacement is minimum in comparison to path first and the path second. Now if suppose a body is dropped from here, then what will happen? The body will take maximum time to move from A to B, and body will take minimum time from moving to A, Q, B. This is because here the body is getting more velocity. The velocity will increase. So because of that, this body will move faster at this point and will reach before the body moving on this AB. Time taken by body. Now what we have? That we are having this again the points. This is now your A, this is now your B, this is now your straight line, this is now a path like this. This is now the first path, this is now your second path, and body is moving like this one. Suppose a body is released from here, and then this is also released from here. Now this is released from here. Then time taken from A to B. मान लेते हैं कि ये टाइम यहाँ पर T होता है, and that time taken from taken in path first, this is equal to suppose T1. Time taken in path second, this is now suppose you T2. Then what will happen? T is greater than T1 is greater than T2. It means that the time taken from A to B will be maximum, and time taken from this path first and path second, that will be less than the time taken from A to B. इसका अर्थ क्या है? A से B तक सीधे जो मिनिमम डिस्टेंस है, डिस्प्लेसमेंट है, अगर हम उस पर बॉडी को डालते हैं तो यहाँ पर जो इसकी जो स्पीड होती है वो इसकी जो टाइम होता है यहाँ से यहाँ तक का पहुँचने का वो कम होता है, सॉरी ज़्यादा होता है. इसमें टाइम और कम लगेगा, इसमें टाइम और भी कम लगेगा. So this is the degree descending order. Or we can say that this T2 is greater than T1 is greater than T1 T, then this is the ascending order. Ascending order. So time taken from A to B is maximum, and time taken from to the third path is the maximum. So this is what, that when the body moves through the different paths between A and B like this, then it will take the different times. Time will be minimum for this one, and then more for this, and this is now last, this is now very high. So this is about the distance and displacement. You can have the similarity that both are measured in meter, both have the same dimensional quantity, dimensional formula. This is the similarity between them. So thank you very much.